for the heavier elements and for the lighter elements, we see a different kind of activity that happens, which is called as radioactivity. So what happens is that an unstable nucleus undergoes a decay. Unstable nucleus are the ones which are very heavy or the ones which are light. So they undergo a decay to become more stable in a way, and this is referred to as radioactivity. So the radioactivity actually is of three types: alpha decay, beta decay and gamma decay. Now what happens is these are three different ways in which a decay happens in an unstable nucleus. So now what are these decays? These are three different kinds, and this is a very important part for you from prelims point of view. Now when it comes to the first part, that is alpha decay, what happens in an alpha decay is that the mass number of the product nucleus is 4 less than that of the decaying nucleus, while the atomic number is decreased by 2. So basically what happens is, if you look at this diagram, that you have plutonium which is getting converted into uranium, and there is a release of helium nucleus. So this is something that can be called as alpha particle. The nucleus of helium that is getting generated here. So helium nucleus can be called as alpha particle. So whenever this is happening, what is happening is atomic number and mass number both are changing, or you can say both are decreasing. So this is alpha decay. So whenever alpha decay is happening, remember three facts. One, that alpha particle is equivalent to the nucleus of helium. Second, that atomic number will decrease by 2. And third, that the mass number will decrease by 4. Now since atomic number is changing, atomic number is the most unique property of any element. If you change the atomic number, you are essentially changing the element itself. So since it is the most unique feature of an element, changing atomic number means you are changing the element itself. So from plutonium we see that it changes into uranium and alpha particle is emitted here. So this is what is called as alpha decay in case of radioactivity. Then you have something called as beta decay. Now in beta decay what happens is the nucleus spontaneously emits an electron or a positron. What is a positron? Positron is an antiparticle of electron. So what that means is that the charge is same but positive in case of positron, mass is same. Because if you talk of an electron and you talk of a proton, what happens is in electron and proton also the charge will be same, but we have already seen in the very first slide that the masses are different. So that's why proton cannot be called as the antiparticle of electron, but positron can be called as the antiparticle of electron. So what will happen in beta decay is either there will be an emission of electron or there will be an emission of positron. And in beta decay the mass number remains unchanged. The mass number remains unchanged but the atomic number changes. The atomic number changes. So if you get a question in which of the following types of decay there is a difference in mass number, that is option A alpha particle decay, option B beta decay, option C gamma decay, option D both A and B. Let's say if you get a question like that, so what we know about mass number change is that mass number would change only for alpha particle, it will not change for beta particle. When it comes to atomic number will change for both. A very important information for your prelims examination. So what happens is, if you look at this diagram, carbon 14 will undergo a beta minus decay and form nitrogen with an electron being emitted, so that's why it is called as beta minus decay. And when beta plus decay comes into picture, a carbon 10 you can see here is getting converted into boron 10 with the emission of a positron, and with the positron you have emission of a neutrino also. So when you talk of neutrinos are always produced due to beta decay, or they have always existed ever since the birth of the universe. So ever since the birth of the universe, some neutrinos were formed which are roaming all throughout the universe right now, and apart from that, new neutrinos are also produced all the time whenever a beta decay happens in a given element. So these two become the source of a neutrino production. So these two are the types of beta decay that we have, in which either there will be a release of electron or a positron. In that case, what happens is the mass number remains unchanged, but the atomic number changes. Then the third kind of radioactivity that we see is gamma decay. Now when it comes to gamma decay, here neither the atomic number is changing nor the mass number is changing. Both will not change. Only change that happens is that the nucleus in the excited state spontaneously decays into ground state. A photon is emitted with energy that is equal to the difference in the two energy levels of the nucleus, and that's why this is the form which is called as gamma decay. So neither the atomic number is changing nor the mass number is changing, only the energy level of the nucleus is changing. From an excited state, now it comes to the ground state, which is much more stable than any excited state. This is what would happen in case of a gamma decay. So typically a gamma ray is emitted when alpha or beta decay results in daughter nuclei or nucleus which is in excited state. If you look at this reaction, if the daughter nucleus here is in excited state, then it would undergo gamma decay even further and then convert into its ground state. So similar thing would happen for alpha decay also. So if you look at this diagram, the excited nucleus will emit gamma photon and then it will convert into relaxed nucleus, or you can say the ground state. Now one more aspect that you should know here is about the penetration power. Penetration power of these three kinds of particles that we have. So the alpha radiation, if you see, even if you have a piece of paper, it will be able to stop alpha radiation. But that would not be sufficient for beta radiation or gamma radiation. You need a thin aluminum foil or metal for stopping a beta radiation. But gamma radiation would even cross through that, and it would have a tendency to cross through even a lead if we have. So for example, if you look at X-rays, X-rays is something that would be stopped by lead, but if we are talking about the gamma rays, you definitely need a concrete structure. So that's why if you look at any nuclear reactor, what the nuclear reactors have is a concrete structure all across them, so that the gamma rays which are there in the excited state or very high energy state, they should not go out of the reactor vessel. Because if they go out of the reactor vessel, you have a possibility of a nuclear accident to happen. So that's why a concrete structure will be seen all across the nuclear reactor that we have in a given facility. So this is the third kind of radioactivity that we observe.